What if I told you that one of the most powerful secrets to writing great code isn't about adding complexity, it's about hiding it? Welcome. Today we're going to unpack a huge concept called encapsulation. And honestly, it really is one of code's best-kept secrets. Let's start with a question that, believe it or not, gets right to the heart of this whole thing. How do you drive a car without being a mechanic? I mean, think about it. You don't need to know a single thing about internal combustion or gear ratios to pop over to the store, right?
Of course you don't. You just use the interface. The steering wheel, the gas pedal, the brakes. These simple controls let you operate an incredibly complex machine. All that magic is happening under the hood, but you don't need to see it. In programming, we call this a black box, and it's an absolutely essential idea for building good software.
Okay, section 1. Data and behavior bundled. So how do we take that black box idea and actually use it in our code? Well, it all starts with this idea of packaging two things together, the data itself and the actions you can perform on that data.
And that brings us to our star of the show, encapsulation. At its core, it's about bundling an object's data, what it knows, with its methods, what it can do. They're fused together, locked away in a single unit, kind of like a little pill capsule.
Now, what's so cool about this is the discipline it forces on us. The source material puts it perfectly. A data type is manipulated in a disciplined manner through a set of predefined operations. This means you can't just barge in and start messing with the data any way you want. Nope, you have to follow the rules and go through the proper channels.
And that idea of following the rules leads us right into a related concept, information hiding. If encapsulation is about putting everything into a box, information hiding is about sealing that box shut. It's all about concealing the messy internal details and only exposing the parts that the outside world absolutely needs to see.
All right, section 2, the class, a digital capsule. So we have this idea of a digital capsule, but how do we actually build one? What's the tool that makes this happen in a language like Java?
The answer is the class. You can think of a class as the blueprint for our capsule. It's how we take an abstract concept, an abstract data type, or ADT, and make it real. So you might have the idea of a stack with rules like add to the top or remove from the top. The class is what turns that abstract idea into actual working code. Okay, and this is where it all clicks. Take a look at this array stack class. On the left, you've got the internal data. See that little word private? That's our wall. That's the engine under the hood. The outside world is not allowed to touch this stuff directly. Now look to the right. That's the public interface. These are our pedals and steering wheel, simple commands like push and pop. This is the only approved way to work with the stack. This split between private and public is encapsulation in action.
Moving on to section 3, hiding your implementation. So we've got this wall, right, between the private data and the public methods. But why? Why is hiding all this stuff so important? Why go to all that trouble?
It really all comes down to that one little word, private. In Java and a ton of other languages, this keyword is basically a giant keep out sign. It's the programmer's way of building that wall and telling every other piece of code, hey, you are not allowed in here. You want something? Go talk to my public methods.
And here's exactly why that matters. On the left, we see the risky way. Some other code is trying to directly mess with the stack's internal top variable. This is a total disaster waiting to happen. It's like jamming a wrench into a running engine. But on the right, we have the safe way. You use the public push method. This lets the class handle its own business, follow its own rules, and make sure everything stays clean and consistent.
Okay, let's zoom out for our last section here. Section 4, why encapsulation matters. Why is this such a fundamental part of programming? What's the big picture reason this matters so much?
Well, the payoff is massive. It really comes down to three things. First, security. Your data is protected from being corrupted accidentally or otherwise. Second, and this is a game changer, flexibility. You can completely rip out the guts of a class and replace them with something totally new. And as long as the public interface stays the same, no other code will break. And finally, maintainability. When there's a bug, you know exactly where to look. The problem is contained right inside that capsule, which makes finding and fixing it a whole lot easier.
And that brings us full circle, right back to our car. That idea of flexibility, it's exactly this. A car maker can swap out a gas engine for a brand new electric motor, a massive internal change, but you, the driver, don't have to learn a new way to steer. The interface stays the same, shielding you from all that complexity. So in the end, encapsulation isn't just a fancy term.
It's a shield against chaos. It makes our software more secure, more flexible, and just plain better. So I'll leave you with this thought, especially for my fellow developers out there. What's the biggest mess, the biggest accidental mistake that good encapsulation has saved you from? Think about it.